to make sure we're recording. There we go. All right, so last class we looked at solving linear inequalities. This time we're going to solve polynomial inequalities, and it's going to build off of the things that we've already been doing. In the first half of this unit, we looked at factoring polynomials. In this part of the unit, we've looked at solving polynomials equations. Now we're going to take it a step further. We're going to use all those steps to actually solve polynomial inequalities. Now, just to have a look graphically and just in a basic way of how polynomial inequalities work, we get example 1, where we have two graphs. The one there in dark is our f of x, and the nice light line there is g of x. Now, I want to find the intervals where f of x is greater than 0. All right, so what does that mean? Well, if we're looking at when f of x is greater than or equal to 0, we're looking at this red line. When is f of x greater than and equal to, I should say, greater than 0, which is your y equals 0 line? Well, in this case, at the very beginning here, I guess I'll put it in maroon. That part right here, that lump, is when f of x is greater than 0, part of it anyway. So I'm going to throw that in there, and it is equal to as well. So I'm going to go square bracket from -4 to -2. And close bracket, because at -2, it looks like f of x is also 0. And there's another part where f of x is greater than 0. As it comes up, I'm going to again put it in maroon. It goes down below the red line. Then right here, it's above the red line and shoots up. All right, so our other interval is at 1 all the way to, and I got to do close bracket because it includes 1, infinity. Now, again, infinity, you can't reach infinity, so it's always a round bracket on infinity or negative infinity. All right, so that's when f of x is greater than 0. Now, we have a second scenario here. Find the intervals in which f of x is greater than g of x. So now we're comparing the two functions. And so I go to my graph and say, essentially it's asking me, when is the dark line higher than the line, or sorry, the dark curve? When is the dark curve higher than the light line? And so right here, as I draw in purple, is all the times that f of x is above g of x, but then it goes under it. All right, and then it comes back above it. So in this case, the first chunk, it looks like we're going to have two intervals, and it says again equal to. So they intersect, I would say, at x equals -5. So again, equal to. So I got -5 all the way to, let's see, this second spot here, I'm going to say -1. And I believe it goes below g of x again, and then comes back up to the maroon part, and then from 1 to infinity again. So it's almost the same interval, but a little bit different. So again, close bracket, 1. And I wish I don't have a symbol for infinity, so we'll put it in there. And again, you can't reach infinity. And so close round bracket. All right, so again, that's just a visual representation of solving a polynomial inequality, either comparing it to a number or comparing it to another function, which we are going to do. All right, so number 2. So now this is, like I said, we're building on all the skills we've learned so far. And so I've kind of done the first step here in example 2, where I want to solve this inequality. Now, this polynomial function has already been factored, and that in fact is going to be our first step when we get a polynomial that isn't factored. The next step is to solve, which again we've done. Now I have 3 parts, 3 factors to worry about in this inequality to solve it, to find my x-intercepts. And so the first one is, well, when does x equal 0? X is equal to 0. That would make that part 0. The other x-intercept, I have the x minus 4. Well, what x value would make that equal to 0? Well, x equals 4. All right, now the next part, we have x plus 3. Which x value would make that equal to 0? Well, x equals -3. All right, so now we've solved it. All right, so again, the first step is to factor it. Now that's already done here. The second step is to solve, which we've already done. Now we get to the number line aspect of this. All right, now because we want to solve this inequality. So what I'm going to do is, now I drew this a little bit on my finished note. I teach it a little bit different than I did back then, trying to always get better. All right, so here's my number line. Now I'm going to put my my x-intercepts on this number line. So I'm going to put, we got an x equals 0 here. We got a x equals 4 over here. And I got an x equals -3 over on the left here. It doesn't really matter. This is just a sketch. The key part here is, though, is that at these values, our function is equal to 0. So I got the 0 in there. Now, what we're going to worry about here is what happens in all the in-betweens. What happens after 4, in between 0 and 4, what happens between -3 and 0, and what happens less than -3. Now, here's how we're going to do that. Is to start off, I'm going to look at left of -3. All right, so what I want to do is I want to put a number in to our original function here, sub in for x, a number left of -3. And all I care about is what the sign would be. And so if I put in a -3 or a negative, I'm going to pick a number -4, simple number. Now, if I put in a -4 for our first factor, it's going to be negative. In our second factor, the x minus 4 factor, if I plug in a -4, I have -4 minus 4. It's negative. All I'm worried about is the sign. All right. And then for the last one, x plus 3, if I put in a -4 plus 3, still negative. So now what I'm looking at here is that a negative times a negative gives you a positive. Then times another negative, it means on this interval, our function will be negative. It will be below the y or the x-axis. All right, now I go and do the second part of my, well, I got 1, 2, 3, 4 parts. So I'm going to be in between -3 and 0. Now, if you don't know what I'm doing, this is now the time to speak up. I'm telling you that much. You don't know how I'm substituting in and getting these negatives and stuff. All right, I don't hear anybody. All right, so I'm going to pick another number between -3 and 0. How about -2? All right, so in my first part, I put in a -2. Well, of course, it's going to be negative because it's just an x. -2 minus 4, negative. Then I get -2 plus 3. Ooh, that's going to be positive. And so now in terms of multiplication, I have a negative times a negative, gives me a positive, times a positive. That's positive. So our function is going to be positive on that interval. All right. Third interval. I got 4 of them here. Number between 0 and 4. How about 2? So I plug in a 2 for x. Well, that's definitely going to be positive. Then I have a 2 minus a 4 for my second part. Well, that's negative. And then a 2 plus 3, I'm going to get a positive number there. Whoops, positive number. So now in terms of multiplying, a positive times a negative is negative. Times a positive, still negative. All right, now our last interval. We have x equals 4. So I'm going to use 5 as a number right of 4. And so again, my first part, if I plug in a 5 for x, well, it is positive because 5 is positive. Then I get a 5 minus 4. Positive answer. And then lastly, a 5 plus a 3. Because again, 5 is just a sample number. Any number right of number 4 would be work. And if I have a positive times a positive times a positive, well, it's going to be positive. All right, so now I am ready to solve the inequality. Because it says, when is it greater than or equal to 0? Well, on this interval right here and on this interval right here. And so the answer is, in set notation, it's saying, well, from -3 less than and equal to, because that's what it's asking here, equal to x is less than or equal to 0. And I should say, therefore, f of x is again greater than or equal to 0. And there's another interval. And when x is greater than or equal to 4. And there are the two intervals in which our function is greater than or equal to 0. All right. All right, let's try another one of those. Again, it says solve the inequality. All right, when we have our f of x is greater than or equal to 0 again, using set notation. So again, the first part here, it's been factored, because that's what we're going to do in the next two examples, is we're going to actually have to factor it using polynomial division. But this one's already done for you. And so to start off here, what x value would make that equal to 0? It's a little reverse there, but x would have to be 2. All right, then the next one, 2x minus 1. Well, when would it have to be 0? I could solve that. 2x minus 1 equals 0. Move the -1 over to the other side. And then divide both sides by 2. Well, the other one is x equals 1/2. And then finally, what value of x for the third factor would make it equal to 0? Well, x equals 5. All right. So now it's time to do my interval check. All right, so I'm going to draw my line. Put my numbers on there. All right, so I have, let's see here, 5. I guess we'll do right out here. I want to give myself some room to do those intervals. I got to do these in order here. So I got a 2. Put 2 right here. And 1/2. Now, at those values, our function is equal to 0. But again, what we want to look at is the 4 different intervals. We have 1, 2, 3, 4 different intervals to check out. All right, so first off, I'll go x is less than 1/2. So let's see what happens here. Again, you look into our factors. I'm going to pick a nice easy number to substitute in, which is 0. Left is 0. So in that first factor, I'd have a 2 minus 0. Well, I'd have a positive. 2x minus 0, or 2x minus 1. I put a 0 in for x, I'd get a -1. So negative. And then the last one, a 0 minus 5, I get a minus. So a positive times a negative will give me a negative, but times a negative will give me a negative. So that first part, that first interval is negative. All right, now let's see here. The second part, between 1/2 and 2. Well, I'm going to pick x equals 1. All right, so 2 minus 1 for our first factor, I'd get a positive answer. Let's see here. 2 times 1 for our second factor is 2 minus 1. It'd also be positive. And a 1 minus 5 will give me a negative. And so positive times a positive would give me a negative. Positive times positive gives me a positive. Then times a negative would give me a negative. So put that in there. All right. Now an interval between a number between 2 and 3, or 2 and 5. Sorry, I'm thinking 3. So I'm going to put in a 3. All right, and so let's see here. A 3 into the first 2 minus 3, I've got a negative answer. Then put a 3 in for x for the second factor. So 2 times 3 is 6 minus 1, definitely positive. And then the last part, 3 minus 5, will that be negative? And so let's see here. A negative times a positive is negative, times a negative is positive. All right, then our last interval All right, so let's see here. A number right of 5. I'm going to pick 6. So my first factor, 2 minus 6, it would be negative. Then our second factor, well, 2 times 6 is 12 minus 1. It's definitely going to be positive. And then the last one, x minus 5 or 6 minus 5, positive. And so our interval this time, a negative times a positive is negative. Then times a positive is negative. All right, so it asks, when is x greater than or equal to 0? Well, there's only one spot here. All right, and so that interval, and using set notation, would be between 2 and 5, including them. So 2 is less than x is less than or equal to 5. Now I'm looking at my note, my completed note, and somehow I said this one's positive as well. So you know what? I'm going to check it out. Did I get it right? So again, a number left of a half is 0. Put a 0 in there. That'd be positive. That's right. Put a 0 in here. That's negative. That's true. And put a 0 in here. That's negative. Yeah, okay. So that's right. So between 2 and 5 inclusive would be when we solve this inequality. All right, now